Yo, what's going on, guys? Today we are covering Windows processes. Now, this box we'll show you here, is actually the first in the security operations and monitoring. And I will say, in my opinion, I haven't gone through the whole thing yet, but I would say it's probably one of the most important. And the reason is because whenever you're actually looking at attacks and you're trying to decide, am I compromised? Did something happen? That type of thing. These are huge indicators of compromise, especially from an offensive side. We'll talk about it and we'll discuss how this gets taken advantage of a lot. So, first things, guys, if you guys are enjoying the cyber defense path, I really appreciate the support. We're almost to 1,000 subs. That's the goal, 1,000 subs. So if you guys could go ahead and sub, that helps out so much. And if you guys would like the video and comment below your favorite box so far that we've done, and we're going to keep this train rolling. Don't forget to check out the Patreon. We've got exclusive content on there. We're working on certification paths on there as well. And then at 1,000 subs, I'm going to do a giveaway, probably a cert voucher. So let's go ahead and get into it. All right, the first one was the introduction. That was just getting this box set up and how to RDP into it. You can read that if you want. All right, so first things first is the task manager. Now, this is task manager for this box here. And they're going to show you, okay, look, you don't have any apps. What the heck? Well, if you go to, most of you will know this, but if you go to more details, you get some information. What a lot of people don't realize, or what a lot of people don't do, is if you right-click up here, you can add all kinds of stuff. You can say, I want the publisher, I want the type, I want the blah, 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 and we're going to do this. We're going to go through them. Okay. Now, a lot of people are going to say, well, why is this a big deal? Why do we go through this? Because a lot of, I'll say, inexperienced hackers think they get it, right? They think like, oh, I know how to offensively attack something, and they might. But the problem is what happens on the defensive side. What happens when you're trying to get some experience, get your foot in the door, and they have you as an analyst or something, and you know how to attack someone, but you don't know what you're doing. And when I say that, it's not a bad thing. You know the offensive side, but you need to know the defensive side. And the reason also is because from an offensive perspective, you need to know what the other people are going to be looking for, so that way you know how to evade it. Now, when this happens, a lot of the boxes we work on, especially on Try Hack Me and things like that, especially Metasploit in general, a lot of it is taking over processes. So when you take over a process, for instance, the spooler process, that was just a big attack. That was the print spooler process was a huge print nightmare attack. That was this service. So the question is, yeah, we see it running. That's cool. How do we know if that's malicious or if that's the real process running? And that's what we're going to cover here. So first thing you can look at, obviously the name. I'm not going to just explain to you what the name is. You guys get that. Now you have the type. There's three types. There's there's application, there's background processes, and this is all up here if you guys are wondering. Let's see where it tells you. I'm just showing you guys that. I'm just kind of giving you the cliff notes of what they're saying over here, but I'm going to go through it so that it makes more sense, because sometimes you get to reading these and it's just kind of like dry and you don't pay attention. So yeah, you can see here, there it is, I found it. So the type, there's background processes, applications, and Windows. We know the difference. Background processes are just running in the background. Applications are applications, and then the Windows processes are processes that are needed to run Windows, right? So now you can see the publisher. This is important, but also keep in mind that this can be, we'll say, not verified, I guess. That's the best way to say it. I don't want to say illegitimate, but yeah, it can be. This could say Microsoft Corporation and still not be a Microsoft Corporation application. So keep that in mind. Now the PID, this is the process identifier. You guys should be familiar with that, and it'll tell you here Windows assigns it randomly, but you will see that there's a couple processes that are not assigned randomly, so that's good to know because that can identify some stuff for us. The process name, again, we're not going to cover that. That's the actual executable that's being ran. The command line, this is a big one. So this is the command that's being ran on command line when you open the process. So, for instance, let's say this print spooler service. Now, this is an example. This is not how print spooler service worked. Let's say this print spooler service is supposed to be print spooler, and then you look at the command line, and it actually is a really long command that reaches back to a server somewhere on the internet. Does that sound like print spooler service? Does that sound like the right command was ran? Probably not. So that there could tell you, hey, this might be something we need to look into. So keep that stuff in mind. CPU, memory, all that, you guys get that. But that's also another good indicator, especially the network tab too. Because if you're looking at, hey, we're getting a lot of network traffic and it's coming from, just go down here. It's coming from, I made the names smaller. Now I can't see them. Okay. So it's coming from the Windows Explorer. No, that's actually not a bad one because that actually could have some. But it's coming from, the desktop Windows Manager, right? I just picked one at random. But it's coming from there, and we're getting a ton of network traffic. You might want to look into that because that might not be common for that, right? So that's where you need to have some, and there's some systems and processes that hackers target, and that's what we're going to cover is the main targeted ones here. Okay, so process hacker. So this is Task Manager, obviously. The reason they always show you these native tools, these older tools, because like I'll show you, we're going to use process hacker for the rest of the video. But Process Hacker is a much better tool, but the reason they always show you these other tools is because when you get to big corporations and you work for enterprise environments, you can't just download tools however you want, however you see fit. You have to get that approved and get all that stuff approved. And so to know the native tools is very important because if you take away all hackers' tools, a good hacker can still do a lot of his job. Why? Because he knows how to do it natively. Because that's when I tell, especially newer hackers, I tell them you need to understand the process, not just the tool. So, for instance, people that use Metasploit, there was a good box that I did the other day, and I can't remember what it was, but it was just Eternal Blue. But the box said right in it not to use Metasploit. And the reason for that isn't because Metasploit can't take it over. Metasploit can take it over really fast. It's to learn how to do the back-end processes, not to do the tool, right? Because a script kiddie knows how to click buttons and make a tool work. But a script kiddie, you take away his tools, he's nothing, right? So that's the difference between a hacker and a script kiddie. All right, so this is just showing you that you can run, we'll just go here and show you. It's showing you that instead of Task Manager, we have this Process Hacker, which we're running. You can also just say get process. Froze because I tabbed out. Or I tabbed it. There we go. Get process. And when you hit enter, you can see you got your name, CPU, all that stuff. So you can get it other ways is what they're showing you. PowerShell is very powerful. You can do a lot with it. You could end up seeing all this stuff. Okay. So the first Windows process on the list is system. And the list is just what they're saying here. So this is the order that it's going to be designed basically. So you can see it's PID 4, process ID 4. And you can see here, they're telling you it's always going to be 4, always. Now, why is it always 4? Because that's what it assigns it every time. So if you ever hop on in system, you just are looking through the processes, and system has a PID of 2084. That's suspicious because it should always have 4. It should never have another process. Now, so that's what they're going to kind of cover is what's the normal and then what to look for. So you can see, if we go ahead and go to system and we click properties, we got some information here. Now the system process, or the system parent. So that means what started this process right here. It's the system idle process, which is PID 0. That's just starting it up, right? And you can see it started 10 minutes ago and 10 minutes and 45 seconds ago. So it should start right when the computer booted. So if you booted this computer 10 minutes ago, that makes sense, right? But if you booted this computer 10 days ago and this started 10 minutes ago, again, that's a red flag. These are called indicators of compromise. These are things that you're looking for to see is something out of whack, is something not right. Now, another thing that Process Hacker does for you, you can see it says Microsoft Windows, but it says verified. It is 100% verified that that is the Microsoft Windows process. That is the correct process running right there. Okay. Now the reason it does that, or it can do that, is signatures and things like that. And then here's the actual executable that's ran when that happens. So this is important. Now, if you guys have used certain commercial tools, I've mentioned CrowdStrike a lot because it's a tool I use all the time. But tools like that, they will have, when an attack comes out, they'll have process trees like this, breaking down the order of events and timelines, and show you, hey, this process ran out of nowhere and the PID was 2000. Instantly, they're going to flag it, send it to you. You're going to look at it and go, that's not normal. And you start doing an investigation because maybe someone took over, or maybe something went wrong with the machine and it didn't know what to do and it messed up, right? So you got to figure that out. Okay, so now the next process, we can go ahead and close that. And you can see the next process, session manager session or subsystem right there, SMSS. So you can see right here, there's the parent and it goes down into SMSS. So SMSS is going to start a lot of our next couple. So it's going to tell you this starts in kernel mode, boom, boom. And that's going to, and I'll go ahead and click on this and show you. All right. So the parent system, PID 4, that's the parent. We've got it. Boom, nailed it. Okay. Now, you can see if we go ahead and minimize this real quick, hopefully it lets us still click. It does. Okay, cool. We'll choose the columns, and we're going to add a couple of columns here because I want to show you guys some stuff. I think I went past it. Oh, there's command line. We'll add that. And then if I can find it. All right, I couldn't find it, but that's all right. Anyway, so we're not that worried about it. We'll just click OK, and then you can see the command line. That's where it's starting, right? So we'll go ahead, take a look at it. You see session 0. So that's the big thing right here. So if you go to SMSS properties, and you're looking at it, so what you're looking for now, that's the CRSS. So they've shown here that SMSS starts CRSS and winInt. Now, it starts other stuff, and you'll see this, but it's important that if you see that session 0 that they're talking about here, and you can see it here, session 0, that's the kernel session, meaning that you're not interacting with that session. It's not, when you log in, you're not in session 0. You're in session 1 already, or whatever session you're in. Now, so that's important to know, because if that process is in session 0, it makes sense, right? Because this is a startup process and it's in the session that started up. Now, if this is in a different session, that's not necessarily, it could be normal, but it's not normal for Windows natively. So that means something is off. Okay, so then you can see here, session 1 is when it's created. Now, I'll show you something here. So the CRSS, if you go here and you go to properties and you go to token, you see session 0, and then you go to this one, properties, token, and you see that session 1, okay? So that one has session 0, the kernel level, and then session 1, which is user level. Now, one thing to see here, the parent the parent process, you notice it says non-existent. The reason it's non-existent is because SMSS, when it starts something, it terminates itself. So that's important to know, because if you know SMSS starts that process, then it should not have a parent process starting. That's important. That's very important, because if you ever see a process like CSRSS, which should be started by SMSS, and it has a parent process, it didn't start from SMSS. I'll tell you that. So something suspicious. So you can see here, they're actually showing you the actual registry editor and things like that. We're not going to dive into registries here. It's way beyond the scope of this box, in my opinion. But you can see it kind of tells you what each one's for. So SMSS is responsible for creating environment variables, virtual memory paging files, and starts the WinLogon process. So this should start before you log on. All right, and then you can see here's the normal, right? What you should expect to see. So if we go here, this should line up. Now, image path, system root, system 32. system root, system32, boom. So we know it ran the correct command line at least. Number of instances, there should be one master instance, which is this one, and then a child instance per session. The child instance exits after creating the session. So you shouldn't see a bunch of SMSSs here because it terminates itself after the session. But you might see one pop up real fast because it's starting something. And then user account, local system, that's fine. Start time should be right before the boot time. And you can see here, it lines up. The time, it adds up. Okay, so now what is unusual? Different parent process. So if this is not the same parent process, if it's not system, that's a problem. Image path, if it's a different image path, that's a problem. More than one process running, that's a problem. User is not system. So again, if the user is someone else, that's a problem because it shouldn't be started by anyone but the system. And then unexpected registry entries. So again, that's why they showed you the registry. If you start seeing entries that are unexpected or don't look right, that's a problem. Okay, so now we've got the SMSS starts, and you can see the system tree here. It goes system, SMSS, and then that can now start the CSRSS, which you can see here is client server runtime. And you can see the process is responsible for making Windows API available to other mapping drives. So like when you log in, it's going to start mapping the drives for you and stuff like that. It's getting your stuff ready, basically. Now, all this is happening almost instantly. You don't even notice it. So I wouldn't expect you to log in and hurry up and open this up and see it. Like it's going to be all done by the time you get in. Now, it says here, note, recall the CSRSS and WinLogin are called from the SMSS, okay, which we already knew that. Let's see, was there a question here? I didn't mean to. Yep, what other two processes does it start? And they told us that, CSRSS and WinLogon. So those are the two that are started by SMSS. All right, so what is normal for the CSRSS? Now, again, we know the normal would be there's a session 0 and a session 1, so you should see two of them, right? Okay, and here's the session 0, and here's the session 1. Now, the PIDs should be different over here on your box than over here because they're assigned randomly. The only one that was assigned statically, meaning every single time, was system, and that's PID 4. Okay, so now it says, notice what is shown for the parent processes for these two processes. Remember, these processes are spawned by blah, 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 which self-terminates. So you notice there's non-existent as the parent. That has to remain true, or else it's not being started correctly and something's off. Now, the other thing to look at is when you're on process hacker, which is the program we're using, that is verified. Verified. That's good. That means they are verified. Now, if you open that up and it's not verified, that's a problem. Keep that in mind. Now, Task Manager won't verify it the same way that Process Hacker does, so keep that in mind too. All right, now image path. So this is what's normal. The image path should be csrss.exe, system root, system32. It should be created by SMSS, which will then self-terminate, and you shouldn't see it. Should be created local user or local system account, and then start time. It should start up within right after the second. SMSS should start off right after that. So it should be about the same time frame. Now, what is unusual? An actual parent process, meaning it doesn't say non-existent. That's a problem. The image file path, see Windows System 32. If it's not that, that's a problem. Now, here's where you start to get into it. Subtle misspellings. This is very common. So CSRSS. What if they just put CRSS, right? If you see that, you might think, oh, because you're just looking through it quickly, and that's their point, is they want you to not see it, right? To just turn a blind eye without realizing it, basically, right? So that's the stuff you got to look for because that happens very often. The print spooler attack, a lot of those that are DLL hijacks, stuff like that, a lot of those, they just rename it to something very close. And then file inclusion is the same way. We covered the file inclusion where you could name something the same as a file that you're looking for, but insert it first. So there's a lot of ways you have to really pay attention to the actual spelling and things like that. All right, so now we're in the winint. All right, winint. All right, the Windows initialization process. Got it. This is responsible for launching services.exe, which if you've ever gone here and typed in services.exe, it's just going to show you all the services running on the machine, and it starts them. If you've ever used service accounts, that's very important. Service accounts are using this. Oh, I forgot there's a question here. Which was the process which had PID 384 and PID 488? And you can see here, they have 488 down here, the non-existent process, and 384 here, non-existent process. And it was started by the SMS. That's why. So that's the answer. Okay. So now this is the winInt. This is what starts up your services, which is a big deal. So this should start, again, within seconds of boot time. That's important. Number of instances should only be 1. And then it should be started by the SMSS again. So the parent process should not be non-existent. And then you should see systems32 winint.exe. So you can see there's a theme for the startup processes, which is why a lot of these ones that we've shown aren't really targeted too much anymore. But the reason they still are targeted enough is because if you look at the username here, it is NT authority system. Anything ran by authority system, you want to take it right away because that means you have complete control of that box. All right, so we're looking for subtle misspellings again, multiple running systems again. All right, which process you might not see running if credential guard is enabled or not enabled? So they said here, lsaiso.exe is associated with credential guard and key guard and will be running if you have those enabled. So keep that in mind, and that's what they're saying there. Okay, so now we have the next process is service control manager or services.exe. So winint starts services.exe, and then services.exe is service control manager. Now, here you can see here, it's going to be ran. This is the actual registry location. Those are the services. But when you do actually look at, so this is what they're saying is when this starts up, it saves a last known good configuration. So that's good because if something happens, it can go back to that. Okay, so now this process is the parent to several other key processes, which you're seeing right here, services, host, and you can see they start running right there. Now, what is normal? Well, number of instances, 1. Now, I know you're saying that how's that normal if it's starting all these parent? But there's only one services.exe. There's service host.exe. There's all these runtime broker, all this other stuff. But there's only one actual services.exe, and the rest are underneath it or tree down from it. Okay. So where does it run from? Image path is the same thing, system32. Parent process, winint.exe. So that should be there every time. The winint.exe. This should be verified again. And then you should see it started within seconds of boot time again. So that's important. And then it should not be running as system. And there shouldn't be multiple running instances. Those are alarms, right? And then subtle misspellings. So if you see services.exe running here and you see service.exe, let's say, they take that S off and it's running over here. That service.exe is not services.exe. So you need to take a look at it. All right. All right. And then the question is how many instances of services.exe should be running? 1. Okay. Okay, so now you can see we're breaking through the tree here. We got winit.exe, services.exe, and then we have the service host.exe, which you can see here. We've got a couple of those. So the service host.exe is responsible for hosting and managing Windows services. So this is what actually is hosting those services. So this could have a ton or few, depends on what your machine's running and what you need it for. Now, here we go. The DLL to implement is stored in the registry for service under parameter subkey service DLL full path blah blah. Okay, that's where the DLL process is stored. A DLL is basically a mini executable. So when you run a service or run whatever on Windows, it's going to reach out and run a bunch of DLLs, and those DLLs are mini executables that are tasks that it puts together basically in a package for you and says, here's your program. So even though you're running one executable and it pops up, it's an application, it's beautiful, it looks great, it's actually running a bunch of microprocesses, if you will, behind it, which are called DLLs. All right, which is dynamic linked libraries, by the way, if you needed to know. So the example below is the service DLL for DCOM. Okay, so cool. They're showing us if you go to the actual services here and you go to type in D and look for DCOM. I must have missed it. DCOM launch, and you go to properties. This is the actual service, and you can see it's using local system account. You could change that and look at other stuff if you wanted, or you could change that to another account, which is how a service account works. If I change this to another account and I change the path to a server somewhere else and things like that, that's how service accounts work. Now, there's something important here on the DCOM. They're showing you this TAC K right there, TAC K. So it says here, the identifier in the binary path is the TAC K. So it's running this service host.exe and then TAC K, then DCOM launcher. If you don't see that TAC K, it is not legit because the K parameter is for grouping similar services. So look for that TAC K. That lets you know it's legit because it's grouping those together. If that TAC K is not there, it's not grouping with it, which means, hey, service host.exe is running, but it's not grouping with another, with another service, which is very bizarre. So you might want to start diving into it. All right, so, and they give you extra reading if you really want to dive in deep to a lot of this stuff, but I think it's outside the scope. I think the point of this is to understand how Windows works so that if you see an indicator of compromise, for instance, you see CSRSS or CSRS, not SS, running or something like that, something that's obscure, you can automatically go, hey, let me look into it a little bit. Because just because something's obscure doesn't mean it's necessarily an attack, but it's something you need to look into. Okay, so this one here is the image path. Boom, same thing. System32. Parent process is services.exe. So you need to know that. If you're looking for it, it'll say parent process. Okay, and then here, this is a big one. The command line should have that TAC K in there. So that's big. And then, so what is unusual? If it doesn't have the TAC K, the subtle misspellings again, if the image path is somewhere different, and then if the parent process is something different. Okay, so now LSAS. You've probably heard of LSAS before, Local Security Authority, it's Subsystem Service. If you've heard of it, you know kind of what it does. Excuse me, it's pretty much in charge of your logging in and things like that. It creates security tokens for security count, AD, net login. It uses authentication packages specified in the registry, excuse me. You could read more about it, but common tools such as Mimikatz use this to dump credentials. They mimic their processes and hide and play in sight. Okay, cool. So what does that mean? They mimic their processes? Exactly like we said, look for misspellings, things like that. But basically, what's normal? Parent process, you need to know for LSAS is winit.exe. Number of instances should only be one. That's another big giveaway. And then local system is the user account. If you see any of these, especially if you have a machine that doesn't have any service accounts on it and you see that someone, or if you go to username and click it and you see that someone's using it to log in, like this one here, you can see is admin, but you see something using a service account, that could be a red flag for you as well if you don't use service accounts. So subtle misspellings, again, perfect example. All right, now what is the parent process for LSAS? Winit.exe, we covered that. Okay, so now win login. All right, this is the responsible for handling the secure attention sequence. This is the Control-Delete that you push in to start entering your username, password, that type of stuff. So it's right before the actual login. It's going to handle how you log in, that type of thing. And then, like it says here, it's going to use user init.exe. It loads the user shell. Okay, let's see. What is normal? So we need to know what's normal here. What are we looking for? You can see here it should be in the first session, not zero session like some of the other ones. That first session is the user session. Okay, you should see that here the parent process does not exist because it's started by the same process that terminates itself, which is, where is it? Right here. It should tell you what it's started by, but either way, it should. There we go. SMSS launches the process. So it deletes itself, terminates itself, whatever you want to say. So shouldn't have a parent process. So right off the bat, that's a red flag. The shell value in the registry other than explorer.exe. So if you're really diving in, you can look at the registry and take a look and see, hey, this shell should only be explorer.exe. But again, I think the registry is outside the scope of this box specifically because this is getting you introduced to this, not having you deep dive yet. Okay, so an actual parent process, again, if that's unusual, there should not be a parent process. And then the start time should be within the first instance. It should be within a couple seconds. Additional instances occur as new sessions are created through remote desktops, switching logins, that type of stuff. So you might have that, but the initial session should be within a few seconds. Okay, and then the last one, explorer.exe, the last process we'll look at. As mentioned earlier, this is launched using the user init.exe, and we saw that in the registry under shell. So there's going to be many child processes for Explorer, which makes sense because it's running all these different things that you're looking for in the Windows File Explorer. Now, what's normal for it? Well, you got right here. It's running under System Root Explorer, created by user int and exit. So again, non-existent. You should not have a parent process. User account should be whoever's logged in. That's big because that means if you're looking at your process and it's under your session and your name is John, so you know session 2 is John's session, whatever, and you're looking at it and it's using a different account to log in, that might be alarming. That might be something you might want to look at. So what's unusual? An actual parent process, because it should be terminating. It should be running as an unknown user. That's unusual. It should be running as you. Subtle misspellings. Again, here's another big one. Outbound TCP connections. That's huge. There should be no outbound TCP connections from any of this stuff unless it's set up that way, which you would know that beforehand because you work there. So keep that stuff in mind, guys. Now, what is the non-existent process for Explorer? User.int.exe, user init, excuse me. That is the non-existent process that's being terminated right after. All right, guys, we covered a lot of information. Here's some sources for it. I know this is a lot of information, but the big thing is to recognize Windows processes and understand what's normal and what's out of the norm, that type of thing. They don't expect you to memorize every single process, but they do expect you to know the critical processes and the ones that hackers target, which are a lot of these. So hopefully you guys enjoyed it. If you did, make sure you leave a like, comment, and subscribe. Helps out a ton. And thank you guys. Hope you guys have a good day.